Now again, another oral problem. Suppose there's a river and there's a waterfall here. So if you go at this end, you will have a fall and you may die. You don't have to go at this end. So what you have to do is, this width is 500 foot and the point at which you have to start swimming from there, the waterfall is just at 300 foot. The river is flowing at a speed of 3 miles per hour. Now the question is, at what speed should you start swimming perpendicular to the flow of river? With what minimum speed you can actually swim perpendicular to the flow of river? That means you're starting from here and you're swimming perpendicular to the flow of river. Now what should be the minimum speed with which you should swim so that you don't fall into the waterfall? Okay, by the way, 1 mile is equal to 5280 feet. Now you don't require that conversion actually to solve this problem. You can solve this problem without using this conversion, but still you should know 1 mile is equal to 5280 feet. Now this is not the SI unit, and in IIT JEE or in any other problem you are not expected to get data in such kind of unit, mile or feet. You'll always get them in meter, kilometer or centimeter. So don't worry about it if you don't know it, but still it's always good to know 1 mile is 5280 feet. It doesn't hurt to know. So you have to find the minimum speed, and I'm counting on you that you are already working to find out the minimum speed, because this one I'm not going to work out. This is your job and you have to do it. And the minimum speed with which you can go in order to avoid dying is 3 is how much? I think it would come out as 5 miles per hour. Maybe 5 miles per hour. I'm not sure of the answer, so I'll have to solve it now. Let's see. The minimum speed that you would have, and since you are going perpendicular, then the time it would take for you to go would be 500 upon V min. Okay, and you would drift in the waterfall, and the time it would take for you to drift and fall into the waterfall would be, the distance from here is 300 feet upon the speed. The speed is given as 3 miles per hour. So this is the time. This is, if you don't cross on the other side within this stipulated time, then you're going to fall in the waterfall. So considering the critical situation, you just crossed the river in this amount of time, 300 feet upon 3 miles per hour. So this is the time taken to go on the other side. So the time taken from here is 500 upon 500 feet upon V min is equal to 300 feet upon 3 miles per hour. So feet 0.000033. V min would come out as 5 miles per hour. Okay? Okay, bachcho. Okay. Now let's solve another easy problem. This one you may have to use your pen and paper. Suppose there's a pond like this, and on a calm, quiet day when there is no air flowing, there's some water inside this pond or a lake. Suppose a lake, not a pond. There's a lake, and you swim. You start from this point A, and then you go upstream. There's water is still. You go on the other side to the point B, and you come back. The time taken maybe, suppose, is T1. And suppose on the other day, when the air is blowing in this direction, air is blowing like this, then there will be some water current in this direction. On that particular day, again you do the same job. You travel to the other point and then you come back. on the previous day, then when there was no air flowing and the water was still, you started from A, went to the other point and came back. The time taken was T1. On the windy day, the same job takes time T2. Now you have to compare and find out which one is greater, T1 or T2. The job is pretty damn easy, but you have to do it. Let's see, the velocity, suppose the width is W and your speed is V, Vm, or V, speed of the man. So the time that you're going to take for the half of the journey is displacement upon velocity Vm, and for the full journey is 2W upon Vm. So this is going to be T1. Okay. Now let's see T2. On a windy day, when the air is flowing in this direction, to go on the opposite side, your speed would be decreased because the current would be in this direction. Water current would be in this direction. So let's suppose the water current's speed is VW. Or then let me make it as D. Let's make the width as D. Okay. Now on the first half of the journey, the speed would be whatever speed the man has and the opposing speed, the speed of the water. This is the time taken. And for the other half, actually the water current will help the swimmer. Vm plus Vw. This is going to be the total time taken. So if you calculate this, you will get something like this. Okay, yes, you will get this. You will get this actually. Fine. Now you have to compare. This one is greater or this one is greater. This is a fraction. This will be less than 1. And you're subtracting something from 1. So the denominator is less than 1. So the whole thing is 2D upon, this is written actually, (2D upon Vm) into this thing. This thing is greater than 1. This thing is greater than 1 because the denominator is less than 1. So this thing is T2. T2 is greater than T1. So the journey is going to be faster on a quiet and calm day rather than windy day. We can see from here. T2 is greater than T1. Okay.